Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Shardanagar Baramati. Let's start. Today's lecture on molecular orbital theory, lecture number 15. In this lecture, we learn about molecular orbital energy level diagram of O2 molecule. In the MO energy level diagram for O2 molecule, we study how that diagram is drawn and explained with the help of different points. So, O2 molecule consists of two oxygen atoms and 8 electrons in each atom. The electronic configuration of oxygen is 1s2, 2s2 and 2p4. In this oxygen molecule, the 1s orbital is lower energy, so it does not take part in the bond formation. Thus, that 1s orbital remains as a non-bonding orbital. Only 2s orbitals of two oxygen atom and 6 2p orbitals of two oxygen atoms combines and forms 8 molecular orbitals. Means 8 atomic orbital of oxygen atom forms 8 molecular orbitals in oxygen molecules. Here 2s and 2p orbital of oxygen atoms are well separated in energy. So, in between the first atom's 2s orbital and second atom's 2p orbital, interaction is not possible, and first atom's 2s and second atom's 2p orbital not forms any bonding. So energy sequence of the oxygen molecule is given in the sequence sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2px, pi 2py, pi 2pz, pi star 2py, pi star 2pz and sigma star 2px. So up to the nitrogen, energy sequence is some different because up to the nitrogen molecule, the energy of 2s and 2p orbitals are close, and because of that 2s of first atom and 2p of the second atom and vice versa interact with each other. So first atom's s orbital and second atom's p orbital have interaction, and so energy difference or energy sequence in that case is different, and we have seen that already in the examples of nitrogen, then carbon, boron and other examples. So you see here, this is the MO energy level diagram for oxygen molecule, and its pictorial representation is given in this diagram. In this diagram, you see here 2s atomic orbital of first oxygen and 2s atomic orbital of second oxygen combines with each other and forms one bonding sigma 2s molecular orbital and one anti-bonding sigma star 2s molecular orbitals. So this bonding molecular orbital is formed when wave functions of two oxygen atomic orbital is same, and when wave functions of two oxygen atomic orbitals are different, then anti-bonding sigma star 2s molecular orbital is formed. This 2p atomic orbital of first oxygen and 2p atomic orbital of second oxygen interact with each other, and there is formation of sigma 2px, pi 2py and pi 2pz molecular orbitals when wave functions of first atomic orbital and second atomic orbitals were same. Now, in the higher energy antibonding molecular orbitals are formed, in that pi star 2py, pi star 2pz and sigma star 2px molecular orbitals are formed by combination of these two atomic orbitals when wave functions are different. So when wave functions are different, then these antibonding molecular orbitals are formed. So in this way, in oxygen molecule, 8 atomic orbital combines and 8 molecular orbitals form. In that, sigma 2s, sigma star 2s, then sigma 2px, pi 2py, pi 2pz, pi star 2py, pi star 2pz and sigma star 2px. These 8 atomic orbitals are formed. In oxygen atom, 2s and 2p have sufficient difference, and because of that, first atom's s orbital and second atom's p orbital have not any interaction, and because of that, here this interaction is not shown, and the energy difference between sigma star 2s and sigma 2px is sufficient, and because of that, here repulsion is not formed, and so in the oxygen molecule, sigma 2px energy is lower than pi 2py and pi 2pz. So this is the MO diagram for O2 molecule. Now we see electron filling in the O2 molecule. So in the oxygen atom, here 2 electrons present in 2s, 4 electrons present in the 2p. So total electrons are 6. 6 plus 6, 12 electrons are filled. When that 12 electrons filled, then energy sequence is sigma 2s, 2 electrons firstly filled, then sigma star 2s, 2 electrons filled, sigma 2px electrons filled, then in pi 2py and pi 2pz single electrons firstly filled and then pairing is formed. Remaining 2 electron filled in antibonding pi star 2py and pi star 2pz. So in this oxygen molecule diagram, here we see 2 unpaired electrons present in the antibonding molecular orbitals. And from this electron filling in molecular orbital diagram, we write the MO electronic configuration of O2 molecule. So while writing the MO electronic configuration of O2 molecule, the presence of non-bonding 1s2 electron is shown by the capital letter K, because these 2 electrons are present in the first shell, and that shell is denoted by the letter K. There are 2 oxygen atoms take part in the bonding, so letter K is repeated and we write KK repeatedly. The remaining 12 electrons of oxygen molecule is filled in the molecular orbital diagram according to the above principle and Hertz's rule of maximum multiplicity, and from that the molecular orbital electronic configuration of O2 molecule is written as KK sigma 2s2 sigma star 2s2 sigma 2px2 pi 2py2 pi 2pz2 pi star 2py1 and pi star 2pz1. Now from this electronic configuration and electrons filled in the molecular orbital we can write the energy evolved. We calculate the energy evolved during the formation of O2 molecule. So for the calculation of energy evolved, there is simple formula that energy evolved is equal to number of electron in bonding molecular orbital into minus beta plus number of electron in anti-bonding molecular orbital into plus beta. We add the value of electron in bonding and anti-bonding orbitals. So in bonding molecular orbital, 8 electrons present, and in anti-bonding molecular orbital, 4 electrons present. So by calculation, minus 8 beta plus 4 beta is equal to minus 4 beta is the final answer after calculation. So this minus 4 beta energy evolved during the formation of O2 molecule, and this minus 4 beta energy is stabilization energy of O2 molecule. So this minus 4 beta energy is, as compared with nitrogen, this energy is comparatively less, and so we say that oxygen molecule, its energy is less than the nitrogen molecule. But as compared with other molecules like Li2, B2, this energy is higher. Bond order. The number of bonds between the two atoms is called bond order. The bond order of this ion or molecule is given by the formula bond order is equal to number of electron in bonding molecular orbital minus number of electron in anti-bonding molecular orbitals divided by 2. So in bonding molecular orbitals, 8 electrons present. In anti-bonding molecular orbitals, 4 electrons present. So 8 minus 4 divided by 2. So the value of bond order is 2. The bond order is 2 means it contains 2 bonds in between oxygen and oxygen atom, and out of that one is sigma bond and one pi bond is formed. In the O2 molecule, bond length is 1.21 degree Armstrong and bond energy is 118 kilocalories per mole. Now we see the magnetic property of O2 molecule. Just we have seen from the diagram, O2 molecule contains two unpaired electrons, and if unpaired electron present, then it shows paramagnetic property. And so that oxygen molecule shows paramagnetic property. Oxygen molecule shows paramagnetic property, but when that oxygen molecule is converted into different ions, then the bond length and magnetic property is changed. So in this point we see the effect of number of electrons in antibonding molecular orbitals on bond length in diatomic species of oxygen. So in oxygen molecule, there are different species by loss of electron or by gain of electron. So by loss of electron, oxygen molecule is converted into O2 plus ion. Also, oxygen molecule gains one electron and forms O2 minus ion. Oxygen molecule gains 2 electrons and forms O2 minus 2 ion. So in the oxygen molecule, total 16 electrons present, and in that bond order is 2, and it shows paramagnetic property. But when that oxygen molecule is converted into their different diatomic species, then at that time number of electrons are changed and bond order is also changed and magnetic property is changed. So we see here from this table what is the change in the total number of electrons and bond order and magnetic property. So in O2 plus ion, one electron is lost. So number of electrons present in O2 plus ion is 50 and bond order is 2.5 because one electron is lost from antibonding molecular orbital, and so bond order increases by 0.5 and O2 molecule which shows 2 bond. Here O2 plus shows 2.5 bond order, and that O2 plus ion contains one unpaired electron, so it shows paramagnetic property. Now we see the second ion O2 minus. So in O2 minus ion, one electron is gained. So total number of electrons present in O2 minus is 17. But when it gains one electron, that one electron is filled in the antibonding molecular orbital, and because of that the bond order is decreased by zero point 0.5 and it forms 1.5 bond order. It shows paramagnetic property because one unpaired electron is present in O2 minus ion. The fourth species is O2 minus 2. So in O2 minus 2, two electrons are gained and these two electrons are filled in the antibonding molecular orbital which already contains single electron. So in antibonding molecular orbitals, that pi orbital is completely filled. So that bonding pi orbitals and antibonding pi orbitals are neutralized with each other and only single bond is present in sigma 2px. So this O2 minus 2 ion contains only one bond, and so bond order is 1. In this O2 minus 2 ion, all electrons paired, so it shows dimagnetic property. In this way, that O2 molecule, when converted into their different diatomic species, then its bond order and magnetic property is changed. I have given you assignment on this topic. You solve the assignment and submit it. For the assignment, you check the link of assignment in this video description.